By the end of today's video, you'll understand how you can create your own state machines to have separate mechanisms running on your robot while you're following an autonomous path from PedroPathing. So we see it backs up. We can see this now launching the flywheel. The gate now opens. I'm Coach Pratt, and I've been teaching robotics and design for over a decade now. One of the most challenging parts of programming for autonomous is being able to figure out how can you move your robot in space and make sure that it's doing other actions while it is moving itself around in those spaces. And today I'm going to start by showing you my testing setup, which is a simple flywheel with a gate opening mechanism to be able to allow balls to be fed through into this flywheel. I'll step you through a state machine logic and how we might design one of those for a flywheel. And then I'll teach you step by step how you can actually write your own encapsulated program so you can reuse the state machine logic across your different autonomous programs and into your TLDR programs as well. So first, let's take a look at how this might look when it's all said and done. So we see it backs up. We can see this now launching the flywheel. The gate now opens. The gate opens a second time. And then the gate opens a third time. And we transition back to our stop position. I've got a standard holonomic drive here with 4 mechanism wheels, just straight up attached for direct drive. And then I have a couple different servos that are going to simulate my flywheel here. Now I have one continuous rotational servo here, setting up for this flywheel. And we're going to kind of imagine this is DC motor because I presently don't have access to an expansion hub to be able to add additional motors in. We also have a simulated gate mechanism to be able to simulate when we open up the gate and a ball comes through and close the gate so the ball can't come through. So effectively, the whole goal of this mechanism is to be able to spin up a flywheel. We have a gate that's holding a ball off. Once the gate opens, the ball would go through the flywheel, and then we would close the gate so the ball can't go through the flywheel again. I'm also going to show you how I would program this using a DC motor, but I'm also going to do it in a servo just so you can get the idea and the hand of how might you come up with actions using different things. So to understand our programming for the autonomous, it helps if we have a flowchart for our state machine. And I don't think you should be allowed to go in and actually start programming your state machine until you have defined a state machine logic. Because once you have a map, it will make it easier for you to get through. You don't step into the Amazon rainforest or the backwoods of Canada without going in there with a map. You should not do the same thing while you're programming. Heed this warning at your own peril. So you actually are going to have 2 separate state machines running inside of your autonomous. You have one state machine that's keeping track of which path you're currently inside and your chains of paths that you're moving between. Your second state machine is actually going to be inside of your launcher state itself and where you are. The nice thing about this is if you set this launcher state up properly, you'll also be able to use this in your TLDR programs too. So our state for our launcher is going to have 4 different states. We're going to have an idle state, which is our default. We have a spin up, a launch, and a reset gate. And between our 4 different states, one of the states is classified as not busy, and the other state is classified as busy in that the state machine is currently doing something. We will use those not busy and busy sections when it comes to your autonomous. We will not use them when it comes to your TLDR. So let's talk about the general flow. The goal here is to have a state machine that allows us to say, I would like to fire 1 shot. I would like to fire 2 shots. I would like to fire 3 shots. And what it does is it spins up that flywheel. It checks if the flywheel is at a current RPM that we need it to be. It opens up the gate to be able to feed a ball through. Then it closes it. Then it checks the flywheel again, opens up the gate, fires 1 through, closes it. And then it keeps doing this, repeating this loop for the number of shots that we've requested. In this case, could be 1, could be 2, could be 3. So let's say, for example, we ask for 3 shots, and then we send it over to the start machine. Inside our state machine, every single loop is going to be checking. If we have not sent any shots, it's just going to end the program and go back up to idle. It's going to end the state update, and so on. So if you have no shots, it's basically just going to ignore it, and it's going to keep going back to the idle state. If it does have a shot that is greater than 0, it's going to transition into the spin-up state. And when it's inside the spin-up state, it's going to close the gate, and then it's going to set the velocity to our goal velocity for that flywheel. Then it's going to check, is our flywheel at the speed, or is the time up? Now, in my programs, I like to set some sort of maximum time that I'm going to give the flywheel to be able to spin up, because it's possible that you set yourself such a high velocity that it never actually reaches it. So I added an additional safety so that I can check whether the time has elapsed. If neither of these is true, we will exit the state machine, come back in, and then we come to the spin up in this next loop. We again close the gate, set our velocity. So we just keep and hold those things where we are. Then we check, are we at the speed or is our time up? If either of these are true, we should open up the gate and then transition up to our launch state. And inside our launch state, we're going to check, is the gate time up? So effectively, we need to give that servo time to open and enough time for that servo to get from the start position to the finish position for the open. So we give some sort of 20 milliseconds, 40 milliseconds, however fast your servo is. If that time is not up, we go back to launch, and then we check that that gate has actually opened. Keep in mind, the motor is still running this entire time. So once our gate time is up, we can now close the gate, and we'll go back and we'll do this for the reset gate state. And we'll check, is that gate time up? Have we given the servo enough time to get down to the close position? If it's not, end the state and check again. If it is, we check, do we have any shots remaining? If we do have shots remaining, we go back up to the spin up state to make sure that our flywheel gets back to that speed. If we do not have any shots remaining, we turn our velocity to 0, so we turn off our flywheel, and then we transition back to idle. Now you might ask, hey, Coach Brett, why do I need to check if there's shots remaining inside of this regate section or this reset gate section? Isn't this the exact same as checking if I have shots inside idle? And astute observation, yes, that is the exact same, except for our ability to check if our state machine is busy or not busy. And that is absolutely critical for our ability to make sure that we have shot all three through. Because if we were to transition all the way back here, we have no way of checking, are we done firing all three shots? So by checking again one more time in this reset gate state, if we still have shots left, we can go back up to the spin up state where we can then run. And I've realized now I've actually probably made a mistake in this. I probably want to close the gate and set velocity at the end of the idle state before we transition out, so we already come into a check. That'll just make your loop times a little bit faster. So let's actually get to how do I turn that into program now that I know how to actually set this thing all up. We're going over code. I always like to start things up inside their own separate classes. It's a really good practice to get into. So we're going to make our own separate class for our flywheel mechanism. So I'm going to go ahead and right click on my mechanism package. We'll make a new Java class and we'll call this one our flywheel logic. You could call this something different. I'm just pulling it in here for this example state. Then we're going to go ahead and make our first couple motors in here. So in my case, I have two motors. So we're going to make a private servo called gate servo. And in this next point, you would probably make a DC motor EX. Because I don't have access zones right now, I'm going to be using a CR servo or a continuous rotational servo. But you should be setting this up likely as a DC motor. Call this one flywheel servo. Then we need to be able to keep track of how our states actually were working. So we're going to make a private elapsed time called our state timer. And we're going to set that up as a new elapsed time object. Then we can create our enumeration for our actual state machine. I don't like using state machines in integers because it makes things really challenging. So we're going to make a private enum called flywheel state. And we're going to have four states. We're going to have that idle state, the spin up state, the launch state, and the reset gate state. And then after we make that state, we need to actually go ahead and initialize it. So we'll say that our flywheel state of flywheel state, and we'll go ahead and also make this private so that we can't access the state machine outside of the state machine. Now it's time to do a little bit of setup here. And this setup is going to be the gate logic. And this is going to be the constants for our gates for that servo position. So we're going to have a private double for gate close angle. We'll set this to 0. You're probably going to have to tune this one. We're also going to make a private double gate open angle. And we'll set this one just 90 for now. We'll set another one for a private double gate open time. We'll set this one, I think, to like 0.5, just as a rough guess for now. And we'll also have another private double gate close time. We'll set this to something like 0.5, because it's probably going to take the amount of time that it does to open as it does to close. Actually, I might set those to something a little lower, something like 0.4. And this one basically keeps track of the time it takes for the gate to reset to initial position, because you need to give your servos time for them to actually close down. Now we're going to set up some things for our flywheel constants. And I like to separate my code out here with some of these nice little hashes. It just makes it a little bit easier. And I might just also rename this one to constants as well. It just makes it simple as you start to scroll through your code. We'll make a private integer called shots remaining. We'll set that to 0. We'll make another private double. And this one you don't have to make, but I am, because I'm using this for a flywheel and I want to show you how it might work in a DC motor. I'm going to call this one flywheel velocity. And we're just going to set this one right to 0. Again, you don't have to make this one. Now you should make 2 more here. You should make a private double called minimum flywheel RPM. And this one I'm just going to straight up guess and just put 800. So we need to know what our minimum point is. And another private double target flywheel RPM. And we'll set this one to something like 1100. Oops, not a regular colon. And the last one here is a bit of a safety time. So I'm going to make a private double flywheel max spin up time. And this one might be, 2 seconds. So for this one, this is a bit of a safety check, because sometimes your flywheel might actually get up to speed and you'd still like to be able to launch your balls through without completely stopping your autonomous. So this is that check where we say whether we're at speed or that time has elapsed is here where we're going to do that. So now that everything is nice and clean, we can go ahead and make our init statement. So I'm going to make a private void init, and we need to pass in a hardware map with the hardware map variable inside. So this will allow us to basically initialize all of the different motors and things like that inside of this section. So we are going to say that our gate servo is equal to our hardware map dot get, and we're going to say a servo dot class. In this case, I've called it servo. Now you should do this as your DC motor again. I don't have that, so I'm going to say, our flywheel servo is equal to our hardware map dot get. And in this case, it's a CR servo dot class, and this is CR underscore servo is what I've called this. You again should be doing this as a DC motor. There's also a few more things you need to do as a DC motor here. You should probably tune your PIDF. You should probably set to run using encoder. And then you also need to reverse or whatever it is you need to do there, as you typically would. Now we also need to start with our flywheel state. And in this case, our flywheel state is going to be equal to our flywheel state.idle. So we initially start inside that idle state. Otherwise, our state machine won't actually know where we're beginning in, because idle is our default state. That's where we're going to begin. And then we are going to set our motor defaults. So in my case, I'm going to set the flywheel servo dot set power is going to be equal to 0. And I'm also going to set my gate servo dot set position. And my set position is going to be the gate close angle. You always want to make sure you're initializing your servos so that you can have it set at that starting position so it starts powered. Now let's actually start writing our state machine. So I'm going to make a new public void called update. And this is going to run every single loop so we can run and update that flywheel state. So we're going to make a switch state. And our switch state is going to be taking flywheel state here. And our first case is our idle case. Oh, did I spell idle right? I don't think I spelled idle right. Oh, I spelled idle incorrectly. I spelled idle with a D. Okay, that should make things a little bit easier. So make sure you're spelling things correctly as well. So now our case is idle. When we look at our flowchart, we know we need to check the number of shots. So we're going to say if our shots remaining is greater than 0. So first thing we're going to do is we're going to make sure that we make sure our gate is closed. So we're going to say that our gate servo dot set position is going to be the gate close angle. We're also going to spin up our motor. So here is where you'd probably call your set velocity for your DC motor. Because I don't have the ability to set velocity, I'm going to go ahead and just say that this is my flywheel servo, and I'm going to say dot set power, and I'm going to set this to my target flywheel RPM. And I'm actually going to go back to change my target RPM to 1.0, just so that this doesn't throw a huge error in mine. Once we're done doing all of our logic to set up, once we're transitioned into those states, we can also go ahead and grab our StateTimer.reset so that we can start keeping track of how long we are inside these individual states. And we can set our flywheel state to that new flywheel state of spin up. Now, at the end of state machines, we also have to make sure that we do a break inside here. Otherwise, it will automatically transition into the next state, which is not, of course, what we want. So our next case is the spin up case. And here you're free to also set velocity for your motors if you're concerned about that, but they do remember the last command that they were sent until they're commanded to be off. So you don't actually have to put in velocity here if you don't want to. So the first thing we're going to do is we're going to make an OR statement inside of our if. So we're going to say if our flywheel velocity is greater than our minimum flywheel RPM, or we put in two pipes, our state timer dot seconds is greater than our max flywheel spin up time. So this is where we check, is our flywheel at speed, or have we gone past that initial spin up time? If we have, we can now go ahead and open that flywheel gate. So I can say my gate servo dot set position, and I can set this to the gate open angle. And then I can also go ahead and do my state timer dot reset. So we keep track of these individual states. And then we can transition our flywheel state into our flywheel state in the launch state. And again, we have to make sure that we break at the end of our spin up here. Then we can write our case for our launch case. And looking back to our flowchart, I want to check if our state timer is up. So we'll say if our state timer dot seconds is greater than the gate, not gate close time, the gate open time. So that's the amount of time that it takes for that gate to actually physically get to that position. That means that our gate is fully open and we've likely fired a shot. So we can set our shots remaining minus, and this will simply increment by -1 for that. You can also say shots remaining equals shots remaining minus -1, but minus is just a bit of a short form you can use in Java. We can go ahead and close our gate. So we can say our gate servo dot set position to the gate close angle. We can reset our state timer. So our state timer dot reset. And then we can also transition states at this point. So our flywheel state is going to be equal to flywheel state dot reset gate. Then of course, our last case is the reset gate case, where the first thing we need to check based off our logic flowchart is if our state timer dot seconds is greater than the gate closing time. That means that our gate is now in a fully closed position. We can now check if our shots remaining is greater than 0. That means we do still have shots left to make. We can reset our state timer dot reset. And we can transition states again. So flywheel state is equal to flywheel state dot spin up. Otherwise, if we don't have any shots remaining, so our else statement here, we can go ahead and stop our flywheel. So I'll say my flywheel servo dot set power, in this case would be 0, and this would stop the flywheel. And then you can also transition that flywheel state back to flywheel state dot idle. And that's how we can turn our flowchart into a pretty standard state machine logic. Oh, and last thing I need to do is I need to make sure that I break at the end of this. Otherwise, we will transition in again. Now we need 2 more helper functions to be able to put in. We have to have a helper method that allows us to actually start this state machine up and transition outside of the idle state. So I make a public void, and I'm going to call this one fireShots. And I'm going to take an integer for the number of shots that I'm requesting. And then in here, we'll check if our flywheel state is equal to flywheel state dot idle. That should be the capital F. We'll check that we're currently inside the idle state. This is just one more safety check that we can put in, because it's entirely possible in autonomous Brogan that we end up requesting another state or another flywheel launch before we've actually gotten into that or before we finished launching that previous one. So this is just an extra safety check. We can say that our shots remaining is equal to our number of shots. And this method here is the one that's actually going to start our state machine up, because we'll check that we're currently in the idle state. And then inside that idle state, if our shots is greater than 0, that's when we actually start our main logic to start flowing into the rest of this state machine. Last thing we have to do as well is we have to check if our state machine is currently busy. So if rather than the idle or any of the other states. So I make a public Boolean called isBusy, and this is simply going to return flywheel state is not equal to our flywheel state.idle. So if our flywheel state is idle, it's going to return false and that we are not busy. Whereas if it is not in the idle state or any other state, it will return true and that we are busy. So now we have our basic flywheel logic set up. We can now use this in any program that we want. So let's write a quick autonomous to actually pop that in. So I've written up a simple class here for how you might run a PedroPathing autonomous. If you're not sure how you can create path states in PedroPathing, take a look in my video tutorial down below before you continue, because this is the exact same code that I've used in that previous tutorial. So if you follow along, great. If not, I'll give you a quick little 3-second run through of how this actually works. We create our autonomous class. We have our follower as well as a few timers set up for our op mode itself. We have a enumerations for our path states. We have a drive from start position. We have a shoot preload. And then we also have a drive from shoot position to our ending position. So our goal is to do something kind of like this, where our robot's going to start in the top left-hand corner where the blue goal would be, transition back on the launch line, wait to be able to fire some shots, and then transition off of that launch line. So the idea would be inside that shoot preload path state, that's where we would actually run those 3 balls that we want to shoot. We have a few different poses for our start position, our shoot pose, and our end pose. And then we create a few different paths. Because we have 2 paths, we go from that start pose to the shoot pose, and we go from the shoot pose to the end pose. And then we have our main path update here, where we have one case where we're driving from the start position to shoot position. Inside the shoot preload, here is where we're actually going to change the logic today to be able to have that shooting logic. And then here's where we actually end up finishing. Then we have a little helper here so that we can set our current path state as well as reset the timer for how long these paths are taking. We have our initialization statement where we actually set up our PedroPathing. We have our start, we actually go ahead and reset our timer as well as call our path state. And then inside our loop, we update our 2 different state machines. So the follower is in itself is a state machine, and then our state path update is also a state machine. So let's go ahead and actually add in some of this new logic. So inside of our main class here, we're going to go ahead and set up for our flywheel logic here. So we'll do our flywheel setup. And we're going to make a new private flywheel logic, which is what I've called in this class over here. And we're going to call this one shooter, be equal to a new flywheel logic. We also have to make a new Boolean here. So we're going to make a private Boolean called shots triggered. And we're going to set this to false initially, because we need to keep track of some way of when we've actually triggered those shots and if we've set them up so that we can have our state machine not constantly recall those, so that it only triggers once per state. Now down our little helper function here in our public void set path state, we're also going to make sure that we set those shot triggered to false. Shot triggered is going to be equal to false, so that we can initially have it started up. Anytime we transition a new state, we'll make sure that we turn that shots triggered off. And we also have to make sure we initialize that init method for that. So we're going to come on up to our public void init. Actually, sorry, that's down, my mistake. And after we build our paths, or even before we build our paths, we're going to say our shooter.init. And that's actually go ahead initialize. I realized I made a huge mistake here. This is not a private void. This has to be a public void because we have to be able to access that init method from other classes. My mistake. And then inside this init statement, we're going to go ahead and call that with hardware map. So that actually creates all of our server and the shooter and the DC motor objects. Now, last thing we need to make sure we're updating this every single time is we're updating our follower update. We're also updating our state path update. It's also important that before we update our state path, we call our shooter.update, and this will update the state machine on our flywheel shooter. If you forget to do this, your state machine will not work because you will not be updating this every single loop. The thing I really like about this is a fully functional autonomous loop, and it's done super clear. Now we can actually go ahead and add in our logic for this. Since our logic is actually quite easy to grab this inside of our state path update section here. So here's where we're going to come inside of our case, which is our shoot preload. And any other cases that we have shoot, we can actually add in very similar logic in this case. So the first thing we have to do is we have to check if our follower is done our path. So we're going to go ahead and replace a lot of this code today. So in order to know if our follower has done our path, PedroPathing uses if are not follower.isBusy. So that means that if our follower is not busy, it's finished its path and it's holding its current position at the end of that path. Next thing we have to do is we have to check, have we already requested shots yet? If we have not, so we'll say, so if we have not yet triggered those shots, so if not shots triggered, we can go ahead and say our shooter.fireShots, and we'll pass in 3 because I want to fire 3 shots. And then we'll set shots triggered equal to true so that we don't constantly call this over and over and over again. Then we need to check if our follower is not busy. So we'll say else if our shots are triggered and our shooter dot is not busy. This means that our shots are done and we're free to transition. So at this point, now we can go ahead and grab this other logic where we would follow our next path and then set our current path state. So we can go ahead and cut that out and we can delete these sections here. And that's it. Now that we have our state machine logic set up and we have this now pulled into our shoot preload, we can use this same logic here to be able to add in more paths and add in more sections. We can even add in sections where we're turning on our intakes that can be pulling in and having different state machines running for these things. So let's take a look at this in action. So what we should see happen is we should see our robot start at that blue mode, back up to the shoot position, fire through 3 shots, and then move over to the side for those 3 different paths. So 3 different states inside of our driving state machine and 4 different states inside of our flywheel state machine. So we see it backs up. We can see this now launching the flywheel. The gate now opens. The gate opens a second time. And then the gate opens a third time. And we transition back to our stop position. If you like this code snippet or some other different CAD files and resources for robotics, you can consider joining my community down below. I hope that you found this tutorial useful and be able to set yourself up having parallel actions as well as using some traditional state machine logic, which is one of the foundational concepts of robotics. If you have questions, let me know in the comments down below. I'll try my best to be able to answer those for you. And as always, best of luck out there this season. So we see it backs up. We can see this now launching the flywheel. The gate now opens. The gate opens a second time. And then the gate opens a third time. And we transition back to our stop position.